we're going to go ahead and look at section 7.6, rational exponents. So we're going to look at simplifying when we have fractional exponents. So how could we simplify b to the 1/2 squared? Okay, so there's more than one way to think about it, but I could have b to the 1/2 times 2, because I can multiply those, which gives me b to the first, which is b. Okay. Doing that, we'd be using our power of powers property, which we've seen before. Another way we could think about it is if something is squared, it's really b to the 1/2 times b to the 1/2. And we know that when we multiply, we add exponents. 1/2 plus 1/2 is 1. So we would get b. Either way to think about it is perfectly fine. Okay. So today we're going to look at, like I said, rational with fractions. So for any real positive number, b, and for any positive integer, n, if I have b to the 1/nth power, I can rewrite that as the nth root of b. Okay. So here's an example. We want to evaluate 8 to the 1/3 power. Well, you might not recognize that right away, but really what it is it's the cubed root of 8. I can rewrite it backwards. And we know the cubed root of 8 is 2, because 2 times 2 times 2 gives me 8. Okay. So real simple, write in radical form. Okay, so we want to write it with a square root. So in order to do a to the 1/4, this is really just the 4th root of a. The next one is to write in radical form, okay, x to the 1/5 power. Well, I would just write that one as the 5th root of x. All right, now we're going to go ahead and look at two examples where we go the opposite. Okay, we have to write in exponential form. So I have the cubed root of y. So if I have the cubed root, it's really y to the 1/3 power. And then example 4, we want to evaluate 16 to the negative 1/4. Well, let's do a little work before we do this. If I have a negative exponent, I'm going to go ahead and write it in the denominator. So it's 1/16 to the 1/4 power. Okay, now I'm going to write it as a root. So it's 1 to the 4th root of 16. And you can do that on your calculator if you need to. Otherwise, the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So it's 1/2. And there it is, evaluated. Okay. Now we're going to go ahead and look at something else. Okay, I want you to go ahead and remember, okay, we just did this. 8 to the 1/3 power was the cubed root of 8. And really because it's 8 to the 1st power. So now, how would I rewrite this one? 8 to the 2/3 power. Well, we could think, well, this is 8 to the 1/3 squared. Okay, that would get me 2/3. So if I do that, I would have the cubed root of 8, and it would be squared. So that's another way you could look at it. You could write it that way. Or, okay, another way you could think about it is it's really the cubed root of 8, and once you do that, you can square it, all of it. Either way, whichever way you prefer to look at it. So, for non-zero real numbers b and any integers m and n, with n greater than 1, n has to be greater than 1 because it's in the denominator, can't divide by a 0. Okay. I would have b to the m over n is really the nth root of b to the m. Okay. Or the other way that you can think about it, it is the nth root of b and all of that taken to the m. You can do it in either order, whichever is easier. You want to evaluate it and see what's easiest for you to do first. Okay. So example 5 says evaluate 243 to the 3/5 power. Well, I would see, can I take the 5th root of 243? Because I want to get a smaller number if I can first, and then take it to the 3rd. And if I try the 5th root of 243 on my calculator, I get that it is 3. And so it's 3 to the 3rd, which we know is 27. Now example 6 says, write in exponential form. Well, I really know it's y to the 4th to the 1/6 power, so it's going to be y to the 4/6. And if I want, I could reduce that to 2 over 3. So it's y to the 2/3. All right. The next one we're going to go ahead and look at, and I just want to point out before we do that, is that we have 3 is the power, okay? T is our base, and 4 is what we call the index, okay? So whatever is in, if I have, okay, this is another way of looking at it. This would be my index, the x would be my base, and the 2 would be my power. So just a little terminology before we go ahead and move on. So 7, the radius r of a sphere with a given volume v is given by r equals 3v divided by 4 pi, and then all of that to the 1/3 power. Find the radius of a ball whose volume is 77 centimeters cubed. So my v is 77. So I'm just going to plug that in. My radius is equal to 3 times my volume, 77, over 4 pi to the 1/3. Well, I know that the 1/3 is really the cubed root, okay? And then 3 times 77, you can figure out what that is. It's 231 over 4 pi. I would like for you to type this in on your calculator, okay? To do the cubed root, there should be a button that's x. So you type in 3 and then put all of this in. So please check this on your calculator now to make sure you can get it. And then if you cannot, ask me tomorrow in class. So I type this into my calculator, and I get that it's approximately 2.639. So my radius is about 2.639, and I would label my radius in centimeters. Okay. So here's just a few reminders. Okay, we have our product of powers. So here's all of our properties of exponents. So product of powers. When we have products of powers, the biggest thing to remember is to add the exponents. Product just means you're multiplying together. So sorry, this is acting weird. So add exponents, and then let's do number 8. So if I have example number 8, I have x squared times x to the 3rd times x to the 4th. Well, I'm going to add those. It's going to be x2 plus 3 is 5, 5 plus 4 is 9, x to the 9th. The next one, I'm going to go ahead and add those exponents. Remember, when you're adding fractions, the base or the denominator needs to be the same. And if it is, you just need to combine your numerators. So it's really x to the 8 over 5. So there is my product of powers. So remember, when you multiply, if the base is the same, you can go ahead and just add the exponents. Power of powers. We've already been using this rule. Okay. When taking a base to a power to another power, you multiply the exponents. So for example, 10. I would take 2 times 4, which gives me y to the 10th. Okay, here's another example. Number 11. Okay, I take each part to the 1/3 power. So I would get 8 to the 1/3. X, well, 2 times 1/3 is 2/3. Y, 1 times 1/3 is 1/3. And I know 8 to the 1/3 is the same thing as having the cubed root of 8, which is 2. So I have 2, x to the 2/3, y to the 1/3. And that would be my final answer. The next one we're going to look at is the quotient of power rules. So remember, with quotient, or when you're dividing, you subtract the exponents. Okay. So in this case, I would have m to the 5 minus 11, which is m to the negative 6. And then also remember, if I have a negative exponent, I put it in the denominator. So it's 1 over m to the 6th. Here's another one. So let's go ahead and rewrite this a little bit. So I have the 8th root of 81. So it's really 81 to the 1/8 power, all over 3 to the 1/6 power. Before you go ahead and subtract, though, our bases must be the same. 81 and 3 are not the same. So what I would do is think, well, 3 to what power gives me 81? 3 to the 4th, if you check, that's 81, to the 1/8 power. So if I rewrite this, 4 times 1/8 would be 4 over 8, which is 1/2. Now, they both have base 3, so now I can go ahead and subtract them. It would be 3 to the 1/2 minus 1/6. So it's 3. I'm going to rewrite this. This would be 3 over 6 minus 1 over 6. I recopied that. Nope, we're okay. 1/2 minus 6. So that would give me 3 to the 2 over 6, which reduces to 1/3. So it's 3 to the 1/3 power. And how else could you rewrite that if you wanted to? Cubed root of 3. Either one is fine. Okay. And then our last one is if we have negative exponents. Okay, you cannot leave any negative exponent in the final answer. To get rid of a negative exponent, move it to the inverse side of the fraction and make the exponent positive. Okay, so move it to the numerator or denominator, the inverse side, whichever one, and then make it positive. So number 14, I have 3a to the negative 5th. That piece is negative, so I move it to the inverse side to the numerator, so I put in the denominator, make it positive. And I am done with that one. 15, this is negative, so I move it to the denominator, move it to the numerator, and make it positive. So there we go. That's it. So that's our little review of exponents. So just to remind you, you can never have a 0 or a radical, nor a fractional exponent. On the bottom of a fraction. Okay. So let's look at some examples and let's simplify it to do that. So number 16, simplify. The cubed root of 16, well, I would say the cubed root of 16, that's not a nice answer or a whole number. So I would say, well, I do know what the cubed root of 8 is, and 8 times 2 is 16. And I can't take the cubed root of x to the 4th, so I'm going to rewrite it as x to the 3rd times x. So the cubed root of 8 is 2. I'm still going to have underneath my radical the cubed root of 2. The cubed root of x to the 3rd, well, this is really to the 1/3 power, so I would just have x. And then I would have x back underneath the radical. So I'm going to write that a little bit nicer, neater. So it would be 2x cubed root of 2x. 17, we need to go ahead and simplify this one. I'm going to rewrite it. It's going to be 2 to the 1/3 over 2 to the 1/4. My base is the same. The base is 2, so I can do this. So I have 2 to the 1/3 minus 1/4. You can subtract the fractions you want if you want on your calculator. So it would be 2 to the, I would do 4 over 12 minus 3 over 12. 4 minus 3 is 1, so it's 2 to the 1/12. Or you can write it as the 12th root of 2, whichever way you prefer to write it. All right, 18, we want to simplify. So I'm going to do the numerator first. Okay, so it would be, add those two. So x to the 6 over 3, all over x to the 1/3. And you might see in the numerator that says 6 over 3, and you know that's 2, but if you notice we have to subtract the 1/3, so I'm going to leave it as is. So it would be 6 to the 6/3 minus 1/3, so it's x to the 5/3. And you can leave it as x to the 5/3, or we could rewrite it with a radical, and it would be the 3rd root of x to the 5th. Either answer would be acceptable. And one last one, number 19, we need to simplify. So I'm going to combine my numerators first. This is really y to the 1st, so y to the 3rd over y to the 1/2. So I subtract 3 minus 1/2. I'm going to get a common denominator, so I would want it to be over 2. So I would have it would be 6 over 2 minus 1 over 2. If I subtract them, I get y equals 5 over 2. And so there's one option, or you can write it as the square root of y to the 5th. If you want to, you can write the index of 2 in there, but we typically don't when it is the square root. All right, so we're going to go ahead and stop there. That is the end of the notes. Please, if you have any questions, write them down. Otherwise, I will see you later, and have a great day.